Throughout this video, there will be various clips of magnetic levitation trains, or maglev trains for short. The first proposal of these frictionless trains was actually published in the 1900s. Since then, there has been a lot of development in Germany, and testing tracks can be found in California, Germany, Japan, and China. However, the only commercially functional maglev trains run in Korea, Japan, more famously in China. There are two different types of maglev trains in existence: electromagnetic trains, which we have talked about throughout the PowerPoint, but also electrodynamic trains, which we will expand on as well. As said a lot throughout the PowerPoint, electromagnetic suspension for the first type of train uses magnets to lift the car. The attractive forces are between the magnets and the rails, and it is actually propelled by the support magnets on the carriage, providing alternating current of attractive poles and repelling poles, which results in a net forward movement. Now, the other type of train is the electrodynamic suspension. It uses magnets to levitate the car, and it uses principles of superconductivity. So it has superconductive materials that are cooled. The superconductive materials are put on the carriage, and then on the side of the guideway are figure-8 coils. And these coils experience the changing fields. One of them opposes and the other side attracts it. And these two forces cause levitation. The way that this type of train works is that it's propelled from additional coils on the side of the guideway, providing a three-phase alternating current. So just like the first train, it is propelled from alternating attractive currents and also repelling currents. During the first proposal in the 1900s, the main purpose of it was to find a way to avoid any friction, because the more friction there is, the more energy that is lost. So they really just wanted to get trains that could go to a higher speed in a short amount of time, also with not a lot of energy required. These two different suspension trains do have a lot of pros and cons. Both have a pro of longer lifetimes, and they are much faster and quieter. The electromagnetic suspension train is safer for the public because it has a lower magnetic exposure, and the electrodynamic suspension train is safer during a power outage because it won't crash immediately into the guideway since it is levitating. The cons of the electromagnetic suspension include expensive computer systems that are able to control and maintain everything. The electrodynamic suspension also has a high cost for cooling these superconductive magnets.